Good afternoon and a very warm welcome to everyone for the today's webinar on Stratasys F123 series 3D printers, reliable, repeatable, exceptional. So this webinar will be presented by Mr. Ganesh Babu, who is our General Manager in Applications in Additive Manufacturing. To start with the brief of our speaker, Mr. Ganesh Babu, he hails from Bangalore and is graduate engineer from Bangalore. He has been professionally serving Indian industries at various capacities over the last 3 decades, working at various capabilities from design to manufacturing and to productionize parts and products. He has held various senior positions of management associated with subtractive and additive manufacturing. With the additive manufacturing, he has had the privilege of being the first Indian to extensively work on the SGN resin-based additive manufacturing technology from Israel and has been handling business development for AIM Technologies from the year 2000 and 2000 onwards. So to tell more about this GoToWebinar tool, so as of now, everybody will be on a mute. So we will take the question and answers at the end of our webinar. There is also an option to raise your hand. You can raise your hand, we can unmute you, and one by one we can take the questions. Also there is a chat window, chat box, where you can type your questions over there. We can take all the questions one by one. So, and also there are couple of videos in this presentation, so have the best sound quality. I request everyone to kindly use your headphones for better sound quality. And also, as mentioned, I will be sharing the webinar PPT along with recordings in just case if you are not able to attend today or if you missed out anything. So I will be sharing on the registered email ID tomorrow morning. Over to you, Ganesh sir. Please take it ahead.
Thank you, Pranjal. A warm welcome to all joinees for today's webinar. So, well, I'm Ganesh Babu here, already introduced very well by Pranjal. Many thanks, Pranjal, for the introduction. Now, let us get going with what the Stratasys F123 series that I'm going to present to you all today from Stratasys. So, for reliability and repeatable quality, we are now focusing on the F123 series in today's webinar. So, all of you would be able to get to know more about what the capabilities of the F123 series printers from Stratasys are, and I'll take you through with certain case studies, couple of videos, and more importantly, to talk about how F series printers from Stratasys influences manufacturing industries. And there have been quite a lot of manufacturing case studies also, which I have included in today's presentation. So I hope it will be an interesting one to all of y'all. And more importantly, I welcome you all to get in touch for more information pertaining to 3D printers from Stratasys. So, well, moving on, let me straight away take you through with what is that we are going to today talk about. The agenda for today's webinar is as such that we are focusing on Stratasys, the world's leader in additive manufacturing solutions. So let us look at the 3D printing solutions company Stratasys and its additive manufacturing technologies with a brief overview. And then let's focus more on the F123 series of printers, the real FDM from Stratasys. While we talk about the extrusion principle, Stratasys had invented the FDM technology. So hence the real FDM from Stratasys is what we're going to focus on the F series. Along with the F123 series, we also have the F123 carbon reinforced series, CR series. So product overview and manufacturing applications, which will be covered in the CR series. Customer case studies, I'm sorry, there is a typo. F770 launch event, there is a brief introduction to our launch. We welcome you all to register, and more importantly, we'll also get into this session of discussions to clarify your doubts or answer your questions pertaining to today's webinar. Right. Stratasys, the 3D printing solutions company. Now let's take a quicker look at Stratasys. The first choice for polymer-based 3D printers are from Stratasys. As world leaders, it's been more than 3+ decades now since they had introduced the FDM technology. Nearly more than 140, it's close to around 150K plus installations in the industry. And we have today 5 complementing technologies for the polymer additive manufacturing. So multiple technologies and complete solutions today while we talk about applications that could be realized with Stratasys, 5 technology offerings in the additive manufacturing world. So, well, there is also an association. It's not just the machines, it is the materials, it is the software that go along. And we have also across various manufacturing, industrial manufacturing, healthcare, software giants, all of them are customers, Stratasys customers with 3D printers that support their day-to-day work. So let's move on to understand a little bit more on Stratasys, headquartered in Minnesota, Eden Prairie, USA, and Rehovot of Israel. There are dual headquarters of Stratasys with multiple manufacturing locations, and you could see that 13 countries of operations. Well, so as I mentioned, installations exceeding 150,000 plus. It's always Stratasys who have never kept what they invented to run around, but they have been behind the technology. They have been reinventing the technology. They have been bringing out a wider base of materials to address the polymer requirements in additive manufacturing. So never standing still, they have been inventing and innovating. And that's what Stratasys makes them as world leaders today in the additive world. Here's a video for you all on Stratasys.
Stratasys is shaping the world around us. From 3D printed rapid prototypes and design freedom, to manufacturing innovation and production-ready solutions. We believe that what starts with a spark of an idea can now become reality. We see opportunities all around. The products, solutions, and services being developed within our walls today are changing the way things will be imagined, designed, and made tomorrow. Stratasys 3D printing solutions allows us to tap into the unlimited imagination and potential within each of us, helping designers, engineers, and manufacturers transform their capabilities and accelerate their progress across virtually every industry. Stratasys is shaping young hearts, planes with purpose, helping explore the next frontier, accelerating progress, manufacturing earth-friendly efficient designs, and delivering power and energy to the world. Stratasys empowers the dreamers to dream, inventors to invent, doctors to heal, and industry to grow. We are shaping innovation, creativity, discovery, education, imagination, and the possibilities of tomorrow. Stratasys, the 3D printing solutions company.
So, well, it's been truly impressive on Stratasys. So let's now focus on which are the industry verticals that are adapting additive manufacturing like. There are unlimited possibilities. Today, when we look at industries starting from aerospace, education, medical, automotive, dental, architecture, and many, many more. Today, for any designer to conceive in any given vertical, the use of 3D printing enhances their workflow. So for the last 22 plus years, Stratasys India, we have 850 plus customers, 1200 plus installations in India. And more importantly, Design Tech Systems, we are the platinum partners with the largest install base in the country. So we have listed a few of the verticals here: education, automotive, healthcare, consumer products, as well as aerospace and defense. Brief overview of some of our valued customers with Stratasys product lines. Now here comes the best-in-class polymer-based 3D printing technologies from Stratasys. There are 5 leading additive technology platforms that today Stratasys offers. So very briefly today, while we touch base on PolyJet, it's a multi-material resin-based system. Comes with various sizes. Today you have no limitation. What you conceive, you can achieve with endless possibilities for high fidelity modeling. We have stereolithography, best in class, supporting quite a lot of large scale manufacturing as well. And then the focus is going to be on the industrial FDM. Before we talk about industrial FDM, the Origin P3 is a mass production based system, a DLP, digital light processing system, which uses liquid resin as a raw material. SAF stands for selective absorption fusion. Finally, on the far right, what you get to see is powder bed fusion technology. Again, it's a production based system that could qualify to give you cost effective parts when you have to have short limited runs of production that you need using SAF as a technology. But today we are going to focus on industrial FDM. So while we talk about industrial FDM, it's not just prototyping alone. We're going to look at manufacturing tools. How does FDM support manufacturing industries with world-class accuracies, repetitiveness, and more importantly, unmatched material breadth? Today, while we talk about polymers, the additive world does have limitations in terms about the polymers that you see in the injection molding or the production processes. But here we have it with Stratasys, the industrial FDM portfolio offers you a wide variety. There is high performance based materials, engineering grades, many more to talk about. So today the focus on industrial FDM is going to be ideally on the Stratasys F series printer. What you see is an F series printer which should give you best in class when it comes to accuracies and more importantly high strength. There are multiple polymers on a single office-shared system today that Stratasys offers on their FDM technology. Durability as a factor with 3D printed parts, and more importantly, the most low-cost polymer-based 3D printing technology will be the fused deposition modeling from Stratasys. And while we focus on specialty applications, yes, there are materials with FST certifications, biocompatibility, food contact, for medical applications exclusive to medical industries, whole wide array of materials that encompasses to meet stringent manufacturing needs for multiple industry verticals. That's where today FDM stands for. So FDM technology, let's take a look at the schematic here. Well, before the schematic, this is the largest system, which is a workhorse, the Fortis 900 MC. Then we have the Fortis 450 MC and the F series printers. So this is a snapshot, an overview in terms about how the product looks. They are workhorses. Why I mean that is 24/7, uninterrupted with power supply. They can keep going with sufficient materials to print and churn out parts. So the schematic here, we are going to look at what you design. Today, native CAD files can be read by the interface software that could process. Once you submit to the printer, you have the 3D printed part. So you have model as well as support material. Predominantly, on most of the materials, we have soluble support, which is truly a game changer when it comes to Stratasys leading the market in additive. Support material and model material in filament form are contained in cartridges that are driven by drive wheels into a liquefier zone through which the material in a semi-molten state gets extruded in a heat envelope vacuum chamber, which contains the part that needs to be printed. Now, whatever you govern with all the heat and the vacuum, which enhances holding the build sheet and the part together on the platform, gives you parts that are highly reliable that could meet more demanding manufacturing applications. So now quickly focusing on the subject line, Stratasys F123 series. So here we are looking at the first word to mention is these are affordable systems with multiple materials. They're user-friendly. And more importantly, with advanced capabilities, today, the trend of working with FDM, it's a new dimension altogether what Stratasys offers. Also, we are going to look at the carbon reinforced series, the F123 CR series. With composite 3D printing, manufacturing is made much simpler today with a single step solution using Stratasys CR series printers. Now let's go back to take a look at what has been conceived, designed, and manufactured. The old way in subtractive process is going to be time consuming. But today, with the enhancement of material availability, the best-in-class systems from Stratasys, we have the new way. With a single push of a button, you have the most complex and challenging parts that you can print. That's exactly what we talk about. And why do we talk about and emphasize? The reason is industries, the businesses have a choice to make. Once you make a choice, you need to act upon reason. You don't have to lose your opportunities. You have to be very, very quick because there are competitors all around in every given industry vertical. So let's all win together. So let's look at the factor of reliability, the economics with which today investments on an FDM printer can happen for the F series, and an intelligent 3D printer for the entire office. That's exactly where the focus is going to be. Very well supported by GrabCAD. Today we have GrabCAD as a software that supports to read your native CAD data and process the files for printing. That's been the Stratasys intelligence. So high reliability, what is the focus with the F series for high reliability and accuracy? When you look at the reliability factor, there you see that there is no compromise when it comes to accuracy and reliability, and easy to use. Single step processing, doesn't complicate. You don't need high skill sets to manage and use these systems. And more importantly, while we look at the capabilities that these systems offer, the price category today is very much affordable. Now, where do we stand when it comes to competition? Stratasys F series printers, while we look at hard to use or poor print quality or great print quality and easy to use, there you see it's far above. It's much, much easier to use. And while we talk about the great print quality, it's definitely you have the best in class. That's where Stratasys stands when we look at other competitive professional printers or the low priced obvious competitors that are around with the extrusion principle. F series have been, as I introduced Stratasys, they have never stopped innovating. That's exactly where we see that 15 new patents and more importantly, with 43 existing patents, F1233 serves quite a lot of demanding from prototyping to manufacturing applications. Well, we look at F170 and F370 are the two machines in the F series. While we talk about the draft mode, it is 2x the throughput. This is a great advantage when you look at two different modes of printing, the standard as well as the draft mode. And then more importantly, on the office shared systems. These are just the first investments that any 3D printers or a concept designer would like to invest in. While we talk about the lowest of investments that could happen with the Stratasys quality, the best in class with engineering grade materials, along with the PLA option, cost-effective PLA options for initial concept realizations. All these are made possible only with the F series printers. So let's look at the portfolio of what the F170 and the 370 that I talk about. You begin with a 10 cubic inch platform, X, Y, and Z. And then there you see ABS, carbon fiber 10%, PLA, ASA, TPU, and then we have the QSR support, soluble support. GrabCAD print. Now, when you look at Stratasys F370, you have 14 inches on the X, 10 on the Y, and 14 on the Z. And additional materials, you have Viran, and more importantly, you have PCABS, ABS in electrostatic dissipative grade. A whole lot to talk about. More importantly, here is the solution that you have an intuitive interface, multiple material options, soluble support, and with the F370 onwards, you have the Insight software for more customizations during processing. All these can happen along with GrabCAD. Insight is a great tool for processing. And then for remote monitoring of what the printer is doing when you have to run continuous long hour jobs or when you have to remotely know what's going on the printer, you can do mobile monitoring. Here's a quick video on the F series to just give you an insight of how the printer looks and what is the quality with which you can experience. So there you go, a wide variety of applications that have been addressed, and it validates the investments that go on for the F series printer. So let's look at some critical use cases. While we are going to drill down on some of the use cases, concept verification, design validation, functional performance, as well as manufacturing tools such as jigs and fixtures, forming dies, all these are going to be covered in the use case section. So Red Dot, here's an organization that speeds production. How do they do it? For HVAC systems, they're going to look at not just prototyping, but beyond prototyping. That while they talk about functional prototypes, they get it first time right. That's more important. The VP talks about getting parts made on the FDM system that goes on for functional testing that qualifies these parts for being and checking whether the designs are right for the very first time itself. So first time right products are being made possible with the support of FDM technology. So here we have a more complex design where MTech produces impossible part that increases throughput. Now, while we talk about the traditional method and the costs involved, whether it is CNC in comparison, what is the percentage of throughput and how much of investments go in, both in terms of time and cost. Here we have one of the users who talk about eliminating a valve-off problem. 3D printed tool, it eliminates one of the challenging and most impossible part that needs to be made. Because let us also understand that in 3D printing, being a single step process, any complexity is not a challenge. And while we look at Dana Corporation, here they're going to talk about why do I need 3D printers? Now look at the statement, what we get to hear from one of Dana's prototyping managers. By the time a conventional prototype can be made, it is possible to invest large amounts of time and money in a design that doesn't work, which means there's still going to be quite a lot of handwork and iterations in the traditional processes, because conventionally it's a multi-step process. And here they are reiterating the fact that 90% of cost reduction and months of lead time in making complex automotive assemblies. And that's exactly where the value is. Now here we have consumer electronics case study from a design engineer for verification and functional prototyping. They have to validate the models Either they have to do it by rapid tooling. Machined out of plastic is by the conventional process, or they have to use rapid molds. Now, low cost desktop printers are not easy, and more importantly, service bureaus are costly. Takes too much time. Now, while we look at all their pain problems, traditional prototypes have been limited with accuracies as well as for functional testing. But what Stratasys F123 delivers is accurate, reliable builds. And that is where F123 series gives you exceptional accuracy and it qualifies to be a high quality printer. Now, Hyro has to talk again from the design firm about being a lab manager, the challenges that he goes with. Either to make any concept model, they use foam, wood, cardboard, or even clay. Outsourcing is more challenging. Now, when they are looking at all these challenges, they have the F123 series, which gives them the optimal as well as accurate printouts that serves their purpose in quick turnaround time. Now, while we talk about accuracy and reliability, there are various aspects, various geometries which have been taken into account, and Stratasys, well before introducing the F123 to the market, there have been all these tests that have been conducted. And more importantly, F123 stands well within the accuracies of plus or minus 0.2 of a millimeter. While we talk about details, variety, and possibilities, yes, there are 4 slice sites. While I talk about 4 slice sites, you have the standard slice height of 254 micron now, or 330 micron layer thickness, that is 0.1 of an inch or 0.254 of a millimeter that we talk about. But we also have 0.127 or 0.178 layer thicknesses, which qualifies to print small, accurate, intricate, detailed parts, and 8 material offerings. And there are 2 spools with an auto changeover, right? And 2 build speeds, as I mentioned, the draft mode and the standard mode. So that has been on the standard F123 series printer with the engineering grade of material and the standard polymers with which you can be able to print. Remember, these are industrial grade of materials that go in with 3D printing technology of Stratasys FDM. Since these materials are manufactured and supported by Stratasys, they all fall under the industrial polymer grade, and they qualify to meet any stringent test. All the tests have been qualified with ASTM standards. Now let us take a look at industry current problems with 3D printing as well as with traditional machining. Other than the Stratasys product line, we have come across quite a lot in competition where 3D printed parts are weak, inaccurate, and more importantly, they don't hold up when functional testings are carried out. And more importantly, when we talk about other challenges, there are plenty. Now let us look at what if you had a right 3D printing solution. Let us give a thought about why should you need a right 3D printing solution. Because you don't have to have any investments made and try to tinker around those investments or those printers and then be delayed in your project's execution or not qualifying your outputs to meet your customer needs. Now today you have a solution with high strength composite materials that could mean quite a lot in your manufacturing line. And more importantly, when we talk about the software, the printer software, you don't need any specialized training. It's at use. It can be used very easily, and then you don't need any special trainings over there. And more importantly, the materials that qualify could meet most of these stringent manufacturing needs. That's exactly where complex parts are made much, much easier. And more importantly, the functionality aspect is not compromised. And you have more of the time so that you don't need parts to be finished or post-processed or done for manufacturing separately by machining, etc. Here you have highly accurate, repetitive parts that qualify to meet stringent manufacturing needs. So here we are going to look at what is more critical here to stay within your budget when you're going to invest on an F-series printer. That could supplement your manufacturing, right? While we talk about manufacturing, tooling comes as foremost. So let us now address what are those toolings that qualifies to be made possible with the FCR series printer. While we talk about composite 3D printing, It's a quick turnaround today to match and meet most of the demanding custom manufactured tools that offer productivity. Here we are having 3D printed tools that without compromising on the part quality, you have production tooling that you can print. That's where we talk about. So producing strong, functional, lightweight parts. All these qualities make a cost-effective and a viable option for using F-Series CR. So F190CR and F370CR are the two offerings that today's Stratasys are exclusively offering, because here you go with nylon CF10 materials. So parts that are stronger, stiffer, and more accurate. While looking at fully hardened systems, these systems, again, they are hardened because you are using carbon reinforced material, which could actually create quite a lot of wear and tear through the tips and through the nozzles that allow these materials to pass through. Now, ideally, here these are systems that have been fully hardened that could take up any strong carbon reinforced materials, and more importantly, keep delivering you the quality with an extended life. That's more important. A quick snapshot in terms about what the build sizes and the build volumes are. On the F370, again, it matches the F370 standard with 14 by 10 by 14 cubic inches. Now, here we talk about 14 inches on the X, 10 on the Y, and 14 inches on the Z, and a whole variety of materials. So you have the total materials in the spools, either 60 cubic inches or 90 cubic inches, and more importantly, FDM nylon CF10. Now, this is truly a game changer when demanding shop floor applications are needed. I'll be covering quite a lot of applications that meet stringent manufacturing needs in the coming slides. So, well, before that, we also have the key attributes that with which we talk about: ease of use, manufacturing floor ready, and more importantly, functional parts that are highly stronger. And it's a proven technology and a wide variety of engineering materials. Now, here again, you have 4 material base with auto changeover for long unattended runs. That's very unique. And while we talk about, more importantly, the Stratasys technology, the Insight software is for advanced tool path control. So, which means the advanced tool path control gives you an edge and complements your customization while you're processing complex files. Now, GrabCAD Print does allow you to do quite a lot of customization, but more importantly, Insight is a far advanced software that comes along with F370 and above on the FDM portfolio of Stratasys. So with F370, let us remember there are already 9 pre-tuned materials for immediate success, and more importantly, here is a platform which is ready for any additional materials that Stratasys may introduce in the coming days. So now, coming to the F190CR. Well, it's a little larger than the F170 with 12 cubic inches on the X, 10 on the Y, and 12 on the Z. Otherwise, here again, with all the additions, we have the FDM nylon CF10, which is a great game changer when it comes to manufacturing. I repeat this particular point, and with the same key attributes, product attributes, today there is no compromise as long as you intend to have a system that could print repetitive, high quality, stronger, stiffer outputs that are highly accurate. Now let's quickly get to know more importantly on the manufacturing ready of these systems. Now, why does a system become so very durable? And more importantly, it makes a quality statement in the additive industry. Stratasys have spent quite a lot of efforts in having their products for the best performance in the additive world. For any given vertical, there is no compromise. That's exactly where you get to see more than 9,000 plus F-series printers that are already installed in the field. So when it comes to proving repetitiveness and the dimensional accuracies, It's always 99% plus. And moreover, today, while we talk about using or having the uptime of all these printers which have been installed, what is more crucial here to understand is it is not something that today you invest on a printer and then you get into challenges to work around, to correct your systems, or to enable that the systems are not going to stop in between. But you need to have limited, very, very limited involvement in upkeeping your systems. These are workhorses. And the uptime of these systems have been qualified world over, that how well these systems have been used by our customers without much of a downtime. That's exactly where it scores more than 99% plus. Now, for all the investments that happen in 3D printing, there's also an aspect of safety which governs every investment. Now, safety comes first. Let us see how these F-series printers, with one of the best in the industry, would lead us through to explain about what the safety aspects of these systems are.
As it's an office-friendly system, it doesn't outgas. So the materials we use, whether that's ASA, CF10, Duran, TPU, and many others that we have available on this machine, you can be sure that in the office environment you're using it, you're not going to get the smell of the chemicals coming out of the machine. So basically, it adheres to or is compliant with the local standards for airworthiness within an office space. So this machine is actually on. The temperature inside the oven is well over 100 degrees, and it's perfectly safe to touch all surfaces on the machine. Because it's not printing, it allows me to open the door, and even with that temperature inside, it's still safe on the inside because of the insulation. You can see how thick the door is here. That stops the heat from coming to the outside surfaces. We also have a very thick seal around the door here to make sure that we keep that heat and maintain the temperature control inside the machine as well. Here you can see home heating system is also built into the door. It's a very thick, robust one, so you literally can't pull that door open. There's no way of getting it open until the job is finished and the machine isn't safe to do so.
Truly exciting to know that there are various safety aspects which govern in terms of processing polymers. And ideally, while we talk about outgassing, so when you're processing materials, the smell, the polymer which gets processed, the outgassing properties of the material can be at times very disturbing and harmful. So it has been very well governed to take care that these systems are so very robust in nature that qualifies them to be used either at office or on a shop floor, manufacturing shop floor. It doesn't limit. You can have these systems placed well beside your desk and start printing, or in your conference rooms where the meeting can go on. These are very, very quiet systems. They don't disturb you from what's happening around. They very quietly print parts. And today, here you see that one of a printer which is just beside a conventional machine, a lathe machine. So let's look at what machining with composite 3D printing is all about. So how does Stratasys CR series, F series printer supplements the traditional manufacturing technologies with composite 3D printing? So let's look at some of the case studies that are coming in the manufacturing world. So traditionally, metal components with high strength have got replaced with 3D printed composite parts. This is exactly the core. Why is the CR machines are important? Because they directly replace high strength metal parts that have been traditionally manufactured. Because there's no compromise when it comes to the strength of the carbon reinforced thermoplastics. So here you see strong composite materials with the F series CR machines that give them the edge to have quality outputs. These are work holding fixtures, the work holding fixtures for CNC machining. So it's a complementing technology end of the day. Again, let us look at additive as a technology that complements today's manufacturing. That is where, when you look at the complexity of curves, the surfaces, and the features involved in the work holding device or a fixture, when you look at traditional manufacturing, it's going to call for multiple steps, more costs involved, because each given step of operation would call for a program to be run, and you need to use CNC machines to cut your profiles, and different set of tools will be called for various different operations. But the major advantage with working with F-Series CR material, it gives you a single step output that covers all the features that are called for, whether it's going to be the complex curved surfaces or the intricate features or the most highly accurate holes that need to be made in each of these fixtures, all of them in a single go. So here we talk about replacing machined jigs and fixtures. So as I mentioned in the previous slide, you could see how the printing has happened for locating and machining aluminum component. So machining fixtures, jigs, work holding fixtures, or jigs that could actually let tools be driven through them, all these are getting manufactured with Stratasys CR F-Series printers. More importantly, you can print them solid in nature and unlimited geometry freedom. That's more important. And you also have soluble support, which means hands-free support removal, no challenges or no time spent in removing supports. And when it comes to chemical reactions on 3D printed parts, we have these materials which are very, very good for chemical resistivity as well. So industrial equipment for manufacturing is very well supported with the CR printers. Ideally, what we get to see is in heavy industry, transportation, or for consumer products, there is no limitation. You can take it wherever you wish. What you print can actually be used in the manufacturing world of any given heavy industry, whether it is machinery, construction machinery, agriculture, automotive, aerospace. Let's talk about any given consumer goods manufacturing company. We have the best in class materials that could qualify to meet demanding manufacturing applications. So here the tool that has been shown here is a soft jaw, which is going to hold a complex aluminum part. Now this soft jaws are getting 3D printed with CR material, which means ideally that even by holding metal and clamping them together on the shop floor, they don't easily get damaged, and they can be used repetitively on the shop floor. And more exciting news here, we talk about a press brake tool. What is that we talk about here? A 3D printed CR material, carbon reinforced material with nylon, is used for forming metal. And that's exactly what is shown in this particular slide, a press brake tool. And now we are going to look at a jig, drill jig. Now drilling is a process where we are using hardened tools. The drill bit is a hardened tool. While it passes through any polymer, it can cut through. Hence, you're seeing that these jigs are reinforced with hardened metal bushings in order to have a longer life, which means they can be used for multiple cycles on the shop floor. But given the complexity of the jig, and manufacturing it in a single step additive process makes it more convenient, cost effective, and quick turnaround. And thereby, this drill jig plays a very important role for the shop floor when it comes to complex profiles. So machining fixtures. Remember the first slide that I talked about the machining fixture. While we were looking at the CR machine, the very first slide with the split work holding fixture is exactly what you see here, which has been mounted on a vise and tightly clamped together. Now the 3D printed carbon reinforced is the black part, and in between is the aluminum part, which is located inside this two section of the fixture and clamped on a vise, machine vise. And then the cutting operation begins on a CNC machine, where you could see that aluminum is drilled and machined, and there is quite a lot of coolant which is flowing through. So all these are not going to distort the 3D printed tool. That's what I mean, number one. And secondly, these are highly strong and durable. Even if you're going to clamp on a work holding device like a vice, they can hold together the part and help you machine whatever the component is, because you could see that curvature on the side edges of the aluminum. You may have flat jaws as a standard soft jaw, but without 3D printing, getting to that curve means that you're going to spend more time in subtractive machining to make a fixture, which is again cost and time prohibitive. So quick turnaround time. So finally, let us look at some of the system comparison between the F170 and the F190 CR. The most important aspect is for wherever the application needs are. In accordance to that, this particular slide talks about either you would like to have Insight as a customized software along with the F370 and the F370 CR, or you're going to work with F170 and F190 with GrabCAD is number one. Secondly, 10 cubic inches on the F170, whereas a little larger in size when it comes to F190. And similarly, when we are looking at 370, the build envelope size remains same, but with only the addition of materials that today we look upon 370 to be a great game changer when it comes to making manufacturing tools. So now let us focus very briefly on accuracy and reliability. Now, quite a lot of people online, they purchase printers and use the term FDM, but unfortunately these are FFF printers, which means fused filament fabrication as a process, and they are disappointed to the core. Reason, build after build, or including the filament in between, after a small percentage of use, they tend to break, they are brittle, and all these challenges are encountered. But with Stratasys materials, what is more important is consistency in the results that you get. These have been tried and tested. That is what this slide speaks about. Support materials are tested with each of the model material, and more importantly, when you're looking at print performance, there are 300 print performance parameters which are tuned and adjusted, and you don't get all of these elsewhere. So QSR support, what does this soluble support means? It's a quick support release, making most of the complex geometries possible because you're using the QSR support. You can have full assemblies that you can print, hands-free post-processing. That is the design freedom that you have and the capability to build complex, high-quality parts. So standard and engineering grade materials, a snapshot very quickly. So F170 and F370 have a wide variety of materials to talk about. More than 9 materials on the F370 plus ABS, PLA, TPU, Diran, and all these are materials, standard and the engineering grade of materials. And more importantly, these have been tested and proven materials time and again, and industries enjoy working with Stratasys F-series printers with all these materials. And more importantly, these are very, very aggressively priced. We are not very high on the price lines, let us remember. So finally, for all prototyping and education needs, today we are looking at 4 models today, endless possibilities, right? So reliable and accuracy, there is no compromise. And remember, no expertise is required to run these machines. These are simple, office shared systems, we call them, with higher productivity and exceptional quality. So well, before we summarize, what is the common thread that we are looking about? Any given business has to embrace technological advances. And today, that's exactly what I would like to stress upon. When it comes to productivity or competition with rivals, you need to always maintain an edge. And that edge could come only if you have to embrace technological advancements. So the 4th industrial revolution, while we are looking at whether it is going to be globalization, commoditization, or the digital revolution that we summarize all about, the supply chain needs quite a lot of support. Today, it becomes more simplified for the supply chain teams today with 3D printing and the capabilities that the 3D printers offer from Stratasys, right? Now comes the exciting time to give you all information in terms about our most valuable large format printer, the F770, which is going to be launched. Now, while we talk about the F770 launch, we are extending production boundaries. What does it mean? It means a whole lot. Today, we take this opportunity. I take this opportunity on behalf of Designtech and Stratasys to welcome you all on 6th of March. On 6th of March at Auto Cluster in Pune, we request those of you all who could make it possible to register and please join for an evening session where we are going to launch our F770 printer. More importantly, you'll have both Designtech and Stratasys experts who will speak about the advancements in what the large format printer is all about. And finally, you also have the possibility to witness beyond the boundaries of what we talked about on the F series, the smaller print envelopes. We have large format parts that have been printed with the F770 that would be on display for all of you to look at. So we welcome you all. And here is the snapshot of what the F770 large format FDM printer is all about that we would like to launch on the 6th of March. So want to print large or want to print many? Here is an option to have the large format printer at a very, very affordable price. That's exactly, I would like to underline the statement. When it comes to large format printing, you have very small investment for a very large printer. And when we speak about complexities in geometries and advancements, kindly make use of this particular event where you'll be able to touch and feel and have your questions raised with the experts who will be around. And more importantly, you can contact our marketing manager, Mr. Pranjal, and kindly use the QR code for those of you who would be interested to register and join us for this event. I welcome you all for this event. And more importantly, now it's time to take a few questions if there are any. Pranjal, over to you.
Thank you, Ganesh sir. Thank you for the presentation and sharing the link for our Stratasys F770 showcase event. So as Ganesh sir mentioned, if you wish to attend and if you are in Pune and if you could make out for our event, which is on 6th of March, there is a QR code and the registration link. So just let us know if you wish to attend this seminar. So starting with the questions. So sir, we have one question. So I will just help you with that question. Just a minute. Sir. Yeah. So we have a question from Mr. Arun Kumar. He's asking if cartridge with nylon CF used, could you tell us the temperature range for operating? Basically, the temperature for the cartridge of nylon CF. He wants to know.
See, ideally, the cartridges don't go into the machine envelope, print envelope area. Primarily in the Stratasys technology, if you recall the schematic when I introduced FDM as a technology to you in today's slides, if I may have to go back, I can talk about. Now, there is only a small section of the area which will actually be in a hot state. So the cartridge is at the lower half of the machine where there is a material bay. So that will be loaded at the material bay, which will be in room temperature. The build envelope is only the build chamber that we talk about, where the print head and the build platform are going to have the part in between them, the part gets printed. So ideally, whether it is nylon 12 CF or ABS or TPU for that matter, the raw material from the spool contained in the cartridge will be at room temperature. But when it has to enter into the liquefier zone, primarily, this is exactly where the liquefier zone is hardly around 2.5 to 3 inches in length, which will get into a molten state. And that is going to be the tip temperature, and that varies anywhere between, for the FDM Stratasys technology, starting from 300 degrees, it goes up all the way to 400, 475 degrees as well. So all that governs is what is the type of material that we are going to choose, and it's an automated process where the internal chamber temperature and the tip temperatures, they are programmed in a way and tuned to attain the temperature for processing.
Right, sir. So, if anybody has any questions, you can either type the questions in the chat box, or you can raise your hands. We can unmute you one by one, and you can ask the questions to Ganesh, sir. So, any questions from anyone? We'll just wait if anybody has any questions, or raise the hand, sir. I think there are no questions. If any which ways, if nobody are having any questions, we can conclude this webinar. If later on, if you wish to ask anything, you can just drop us an email. We can answer your query one by one also, or personally on your email. So once again, thank you everyone for attending this today's webinar. As mentioned, I will be sharing the PPT and the recording on your registered email ID tomorrow. So thank you once again. Have a great evening. Thank you, Ganesh sir.
Thank you, and I welcome all of you all for our next session. Until we meet, thank you and take care. Bye-bye.